So in historical geology, we're really only going to concentrate on one of the three rock types. And in this chapter, you've seen that there are indeed three different rock types, and we've talked about the different kinds of minerals. But let's again take a look at our three different rock types. So our first rock type is igneous. And that comes from volcanoes, right, erupting. Now, while igneous rocks are awesome and interesting, they don't really tell us much of anything about the environment. So we're not going to talk about those. Our next is our metamorphic. Now, metamorphic rocks are interesting because those are rocks that are pre-existing, but they get buried, right, really deep inside the earth, and they're subjected to temperatures and pressures, and they make them change. And they can make the rocks change into some really cool rocks like marble. Now, while metamorphic rocks are also interesting, they don't tell us anything about the surface of the earth at all. So we're not going to talk about those. However, what we are going to concentrate on are sedimentary rocks. Now, sedimentary rocks are rocks that generally form from the erosion of other rocks. So what that means is I have rocks that are sitting here, right, at Earth's surface. Okay, we have our tree. So we have a rock, right? Let's say our rock is sitting right here. And as it sits here, right, we've got some clouds, and maybe it's raining on it, and the wind is blowing across it. But in any event, it's breaking down into little particles. And those little particles are traveling, right? Well, those little particles, right, form from erosion. Okay? Well, this is telling us something about surface conditions. So we like our sedimentary rocks. So we actually need to understand a little bit here about where our sedimentary rocks come from. So that's why understanding the origin is important. Now, we learned, right, or it should be obvious, that there are two types of rocks in general, very generically, we can have at Earth's surface. We can either be on the continent or out in the ocean. Now, if we're out in the ocean, our rocks are covered by water. So they're actually protected. So those rocks aren't going to erode very much, right? So there's really no erosion going on there. However, if we're on the continent, most of our rocks are going to be exposed. So these are the ones that are going to erode. So we really need to take a look and see what our continent is made of. The continent is mostly made up of this rock we call granite. And I guarantee you've seen granite before, right? Maybe you have granite countertops, or maybe you've seen it at Lowe's or in an art museum, but you've seen granite before. Granite has a couple of different components. Okay, so let's move on to here. Granite, okay, generally has this mineral we're going to call feldspar. We talked about this earlier in this chapter. It might be sodium, calcium, or potassium feldspar, but either way, it has feldspar. Remember, feldspar is the most common mineral on Earth's surface. It's going to have quartz. Right? Quartz is the second most common mineral. We're going to have things like biotite. And then we're also going to have amphiboles. Now, what's important out of this is our biotites and our amphiboles, these are what we call mafic. They have a lot of iron and magnesium. Okay. They're all, as you learned, silicates, but they have a lot of iron and magnesium. They tend to be really, really dark colored. Our feldspar and our quartz, these are definitely felsic, which means they have a lot of silica and oxygen, okay, in them. Now, what happens is if most of our continent is made up of granite, that means that granite is going to be the thing that's most oftenly eroded. So what happens to these four minerals? These four minerals make up most of the sediment that we see on Earth's surface. So when I say sediment, I'm talking like beach sand, right? Well, let's talk about here. Our amphiboles, they're going to undergo what we call hydrolysis. And what that means is most of those minerals are going to get dissolved into the water. Everything that's left turns into clay. Biotite does the same thing. It undergoes hydrolysis, and most everything that's left turns into clay. Interestingly enough, feldspar does also. Feldspar breaks down very easy when it comes into contact with water. So what you should see here that feldspar, biotite, and amphiboles turn into clay. However, there is one mineral, quartz, that does not undergo hydrolysis. Quartz has a very strong atomic structure, an incredibly strong atomic structure. So, for example, if we were to look at the atomic structure of quartz, it has 4 main components to it, and each one of these is bonded to another component. Okay, so this whole thing ends up being really strong. Okay? And since it's so strong, it remains unchanged. So quartz ends up being one of the most dominant minerals that we find on Earth's surface simply because it is incredibly resistant. And if you remember from earlier on in this chapter, remember quartz has a high Mohs hardness, right? Because it has that really strong bonding structure. So when we get into our sedimentary rocks in the next chapter, we're going to talk a lot about quartz. We're going to talk a lot about beach sand and why quartz is important for helping us understand the different environments. So that's why I wanted to take a moment and talk about where all this quartz comes from on the surface.